All right, so you've got the basics of Python down, but you want your code to stop looking like a school project and start looking, professional. Well, that's exactly what we're going to tackle today, moving beyond the basics to write some really practical, powerful code. Let's jump right in. First up, let's talk about a problem that has probably made every single new Python programmer scratch their head at some point. You write a program, you ask for a number, you ask for another one, you try to add them, and you get 55. What is going on there? Okay, here's the secret. Python's input function, by default, doesn't see numbers. It sees text. To a computer, the character 5 is just a shape, not a value. Programmers call this a string. So when you tell Python to add the string 5 to the string 5, it doesn't do math. It just glues them together. That's called concatenation. What we need is to make Python see them as actual numbers.
Now, the most straightforward fix is something called type conversion. You're basically telling Python, hey, whatever text comes in from this input, I need you to force it to be an integer, which you do with int. Or if you need a number with a decimal, you force it to be a float. It's a direct command, and it works like a charm.
But what if you don't know what the user is going to type? An integer? A float? Well, you could write a bunch of code to check, or you could just use a smarter tool. Let me introduce you to Evaluate. Think of Eval as a brilliant detective for your code. It looks at the string the user gives it and automatically figures out what it is.
Let's actually put this to the test. We're going to use this one simple line of code and see how it handles whatever we throw at it.
So say the user types in 123. Bam! Eval immediately recognizes it's a whole number and tells Python, hey, this is an integer. No int function needed. It just knows. And this is where it gets really useful. If the user enters 6.3, Evaluate sees that decimal point and automatically says, oh, okay, this one's a float. Just one function, evalu, and our code is smart enough to handle different kinds of numbers. Pretty cool, right? Okay, so we've totally solved the input problem. We're getting clean data from the user. But that's only half the story. Getting the right answer is one thing, but making that answer look good, that's the other half. Let's say, for example, we calculate the area of a circle. The math is perfect, but our program spits out something like 50.2656. I mean, that's just messy. All those decimal places look unprofessional, and honestly, it's way more detail than anyone probably needs. To clean this up and make our output shine, we're going to use another one of Python's built-in tools, the format function. It's simple. You give it the thing you want to pretty up, like our messy number, and then you give it a special little code called a format specifier that's basically a set of instructions on how you want it to look. So let's decode the most common specifier you'll use for numbers. It looks like this: width, precision, f. The width is the total space you want the number to take up, including spaces. The precision is simply how many numbers you want after the decimal point, and that little f at the end just tells Python we're dealing with a float. And here's what that looks like in the real world. Check out that first row. We give it the number 10.345 and the format code 10.2f. That means a total width of 10 spaces and 2 decimal places. Look at the result, 10.35. It's padded with spaces to fill the width, and this is a great bonus, it automatically and correctly rounded the number for us. Now, you probably noticed in those examples that the numbers are all pushed over to the right. That's called right justification, and it's the default for numbers. It's super handy because it makes columns of numbers in a report line up perfectly on the decimal point. But hey, what if you want the number on the left? It's ridiculously easy. You just add a less than symbol, a little left-pointing arrow, inside your format specifier. That's it. That one character pushes the number right over to the left side of the space you've given it. Now here's a fun little twist. Strings, or text, do the exact opposite. By default, they're aligned to the left. So if you want to push your text to the right, you just use a greater than symbol. So think of it like arrows. Left points left, right points right. Super simple way to control your layout. And this format function is a total powerhouse. You can use a D for integers, a % to automatically turn a number like 0.75 into 75.00%, and even an E to get scientific notation for really huge or tiny numbers. It's a whole toolkit for making your output look amazing. So, we figured out how to get clean data in and how to present beautiful data out. But the real magic of Python is that it comes with this huge box of tools already built in, ready for you to use. It's often called the batteries included philosophy. Let's do a lightning round of some of the most useful ones.
Need the biggest number in a set? That's max. The smallest? Min. Need to calculate a number to the power of another? Pow has got you covered. And if you need a number's pure distance from zero, ignoring any negative sign, that's abs for absolute value.
Now for the really heavy-duty math, Python keeps those tools in a special box called the math module. You just type import math at the top of your file, and you unlock all this extra power. Need a square root? Math.squareroot. Need to always round a number up? That's math.ceil. Think ceiling. And to always round down, you use math.floor. But Python's not just for numbers. It has some really clever tools for text too. Think of ORD and CRA as a secret decoder ring. The ORD function takes a letter and tells you its secret numeric code. And CRA does the reverse. You give it the number, and it gives you back the letter. They're a perfectly matched pair.
Okay, I'm just going to put a number on the screen. 32. What in the world could 32 possibly have to do with any of this?
Well, it turns out this is a fantastic little piece of trivia about how computers work. In the standard character set that you use, the numeric code for a lowercase a is exactly 32 more than the code for an uppercase a. And this is true for B and B, C and C, all the way down the alphabet. It's a neat little trick that's built right into the system.
So let's bring everything we've talked about together. Imagine we're building a calculator to find the hypotenuse of a triangle. Step 1. We use our smart eval input to get clean numbers from the user. Step 2, we pull in the math module and use math.squareroot to do the hard math. And for the grand finale, step 3, we use format to present that answer cleanly, rounded to 2 decimal places. See how each tool has its job? It's perfect teamwork.
We've covered a ton here, from intelligently handling what users type in, to making our results look polished and professional, to tapping into Python's powerful built-in functions. These aren't just random tips. They're the building blocks you need to take your code to the next level. You now have the tools to control your data from the moment it enters your program to the moment it leaves. So, there's really only one question left. What are you going to build with them?